Okay, so I'm going to start. So, hello, I'm Ronie Salgado from the University of Chile, the same country that is currently in some uprising and lots of protest. So this is a talk that I gave originally at SU this year, and I'm going to do the same talk, but I had to change some part because of some logistical reasons. So if you want to try with Woden Engine, that's the script that you have to use for loading it in a Pharo 7 and a Pharo 8 image. You can take your phones and take a picture of this live if you want. Okay, I see that people are not that much interested. Well, you can also find it with Google, and you will find the GitHub repository for installing it, and it has all of the instructions. So this is not a talk about the low level and the internals of how it is implemented this 3D graphics engine. This is a talk about 3D graphics and art, and I'm going to be demoing some simulations and visualizations in Pharo. This talk is divided in 3 sections. The first one is a brief description of the Woden Engine, mostly about the new features, especially about the new material system. Then I will show some examples, really few examples by using Woden Russell, which is a Russell-style API on top of Woden, but for doing 3D visualizations. It's not as advanced as the one that Milton has just demonstrated. And then I will show some examples by using the new entity systems. So the Woden Engine has a layer design. It has several layers going from very low level in the Abstract GPU, which is a really thin abstraction layer on top of low-level graphics APIs such as Vulkan and Direct3D. The recent versions can be used in a standalone mode for doing an OpenGL style rendering in both Pharo and in Squeak. But that requires a lot of documentation, and it can be a lot of work for usage. Then there is the core of Woden, which is in charge of doing resource management, caching some resources, such as which resources are loaded and which models are loaded, in order to avoid loading multiple times from disk. Then we have on top of that built a scene graph for describing just a 3D scene. That will describe how to do stuff, the model, where they are, maybe how they are moving or animating, but it will not have that many interactions. On top of that, we have 2 extra APIs. One Russell, which is quite similar to Russell 2 or Russell 2D, and the Woden entity system that describes the scene graph, but on top of that has some video game style entities for interacting with them. It supports collision by using the bullet fixes engine and some scripting facilities. So the new feature, in this new version of this graphic engine, is the full adoption of a PBR, physical-based rendering workflow, that is called the metallic and rocks lighting model. And this model is mandated by the GLTF 2.0 model for exchanging format for exchanging models, and it's also the same lighting and material system that is used by Unreal Engine. We have support for perceptual textures by taking some code that is written in Pharo and converting that code into a shader that can be executed on the GPU. I'm mostly using it for accelerating the loading time, but it can also be used for drawing particles and simulating particles. That system is described in a paper for IWST that won the first Paris award this year. And HDR for an auto exposure for color grading and having a high control on the scene. So the new material system has the important feature of separating the design of the texture materials from the lighting system. It was originally designed by Disney, but the current implementation is specified by a paper by the people from Epic Games and is used by Unreal Engine 4. It has 3 textures. The first one has the base color. The second one specifies the normals, or how bumpy is the surface. There's a third texture with 3 channels. One means metallic, a 0 or 1 value on whether the material is a metallic or a plastic, or non-metallic. The second one describes the roughness, and the last one is the ambient occlusion, which is how it's shadow when it does not receive light. That's an example of how these parameters vary. That's from the Unreal Engine 4 paper. And that's how a sample model looks in Woden Engine by applying those techniques. That's how these 3 textures for specifying a sand material look like. And that's how it looks like on the scene, the sand. One way for constructing a 3D scene is by making the scene in a 3D content creation program such as Blender, and then exporting the scene in the GLTF2 format, and then importing it in Woden. There is also another example model from the people that did the GLTF spec. And that is also rendered by using Woden. The only thing that I had to add in addition of the model was the lights. So Woden Rosal is this scripting DSL that is written about the Woden engine. And it's similar in form to the Rosal 2, Rosal 3 that was recently demoed by Milton. And this one is useful for prototyping. So I'm going to show a pair of examples that use this API. So this short script can be used for constructing this, and that was what I was afraid of. Yep. Okay, it seems to be working. So with this script, we visualize all of the classes, the number of the classes, and we connect the classes with their parent classes. Well, this other one, it simulates some kind of board. Those are all examples where you can click and change some colors. You can also move with this game controller. But most of the work is done in terms of the Woden entity system, which is mostly designed for developing a video game. So I will show a simple example with this hot air balloon that you can ride. Oops. Now you can see it. So That is the same texture from before, the same material, and that is a balloon that I modeled in Blender. I exported it, but I also integrated with the entity system, and in this part I can use it, and I can start flying. And of course, it depends on shadow. I can control it with the game controller also. And since this is in Pharo, I can inspect it. So I'm going to try to change and to add some fog. So there are three kinds of fog: linear fog, exponential fog, and exponential with a square fog. That is too strong because the end distance is only displaying between 0 meters and 1 meters. Maybe a bit too big. Not too strong the effect, but you can still see it. Yeah, but going to black is maybe not that much interesting. Maybe to write it. And that looks a bit like underwater. Well, the color for that is the same color of the sky, but will take me a bit of time getting that one. That's how the exponential fog looks like. It's a bit more pleasant to see, or more realistic. And that's the other kind of fog. We will also change the exposure of the camera. Exposure level. That looks like a bit darker, but I actually changed only the exposure. This is something that I have been modeling these days doing here. This is a place in Santiago, typically called Plaza Italia or Plaza Baquedano, which is the place in Santiago where all of the protests start. And all of the manifestations in Santiago, the people tend to meet at that place. But since the uprising, the people have changed the name of the plaza by Plaza de la Dignidad, which means a square of dignity. Well, at least the projector is still working. You can see some trees, several textures. You can see the shadows that are projected by the trees. That's the monument in the center of the plaza. I changed it a bit. I noticed some statue in the entrance here from Salvador Allende. So I just took a picture of that and I put it. That's a picture from the entrance space. And on the left of the picture is those pegs that say the name of this hall that we are sitting on. This is the same balloon that you can ride. That noise is not coming from my laptop, even though the balloon makes the same kind of noise. Oops. This one has the fog with the correct color, so it really looks like fog. And there is a river over there. I'm not an expert in art or modeling, so this is the best that I could do in like 2 days. If you have a really an artist, you can do something that looks a lot better than this. But I think that this still looks quite fine. And this one was the demo that I did for ISOC. For that one, I took a lot more of time. That's the WODANIC Alpha. And let's hope this time this machine does not break. I can also use the control on this. You can see the boat, the volcano. You can see the sea over there. And of course, we can ride this boat. Do you recognize that machine? Yeah, it is working. Although I cannot use a smalltalk-77 on it yet, unfortunately. And you can see that it is moving. Maybe I can turn on the sound. And this broke. I'm changing the starting point. So now we are at the lighthouse. And of course, we can get inside this lighthouse. This is the same that I used at the exact demo, so it does not have that much textures. There you can see some reflections on the glasses, on the windows. In this case, the boat is really far away, so we cannot see it. Let's try to get down to the sea. It's a bit slow for moving here. Okay, I will try to show again the boat. Ah. Okay. I will enable the ambient occlusion, which is a really expensive effect. So you can see it a bit on the borders. So from this corner you can see the lighthouse from another angle. And you can also see the shadow from the boat over there. So this demo shows the. Oh, I was forgetting to say that. So the particles are generated with this Pharo box and converted into shaders. The textures and the terrain from that demo is also generated by Pharo code. And the dashboard in the boat is another WODANIC application running inside. So now I will show how the textures are being generated. Okay, I cannot. That event is not working that very well. I will show you with another example. This is another example I have. And with that code, I'm generating that texture. Let's turn it into something maybe okay. I changed the color of the texture, so it looks a bit more violent than water. So I think that my time has finished. So, any questions?
I saw in all your examples on the top left of the pane you show the CPU.
Yeah.
So that made me thought if you did something to take advantage of GPU.
Yeah. So most of the rendering happens on the GPU, and some simulations are also done in the GPU, but it's quite limited, only mostly for particle simulation and rendering. The main reason of doing that is that the CPU time tells me how much time I'm spending on the Pharo code. And I need that to be less than 16 milliseconds in order to get 60 frames per second. The problem is I'm not measuring how much time is taken on the GPU, because I need to use some graphics API timestamp methods in order to be able to also measure how much time is taken on the GPU for doing the rendering. In terms of how much is consuming on the Smalltalk side, it tends to be quite fun, and probably is not the bottleneck for these scenes.